Let's look at some examples of integrals that involve inverse trig, like this one. So if you look at this integral and you're asked, okay, I want to find the antiderivative of 1 over 4x squared. Well, that looks an awful lot like the derivative of arctangent. Yeah, because the derivative of arctan of x is 1 over 1 plus x squared. But this is not x squared. This is 4x squared. So what we can do immediately is recognize, well, I can change that to 1 plus 2x squared. See, that's the same thing, but now it's pretty clear what you've got here. 1 plus something squared. And then if you need to, you can use substitution. You can say, well, I'm going to let u equal 2x. And then du is equal to 2 dx. So, dividing by 2, I get du over 2 equals dx. So what I can do now is I can replace dx with 1/2 du, and then 2x with u, and here's what we've got now. We've got 1/2 du over 1 plus u squared. And that's pretty obvious that now this is arctangent, right? The derivative of arctangent. So what we have is 1/2 arctan of u plus c. And then you could, of course, say, well, that's 1/2 arctan of 2x if you fancy doing it that way, substituting back in. Okay, so that's an example where we take what we know about the derivative of arctan and we realize, okay, it can look a little different. Instead of 1 plus x squared, here it's 1 plus 4x squared. Now, let's look at another one here. Let's suppose we've got 1 over, and I'll say 4 plus x squared, like this. See? Looks a little different than the previous one. Now, here's our problem with this one. We would recognize this as the antiderivative. We would recognize the antiderivative of this to be arctan x if that were a 1 instead of a 4. But it's a 4 there, and that causes us a little bit of grief. So what we can do is we can say, well, I'm going to factor out that 4. So let's see how that would look. We've got 1 up here. We've got a 4, and now I've got 1 plus x squared over 4. See? I just factored out the 4. Now, I like the way this looks, 1 plus x squared over 4. And notice I can go ahead and factor out that 1/4. And now I've got 1 over 1 plus x squared over 4. Now, we want to use the same technique we used up here for this one. See? Going to use the same technique because what I have now is I have 1/4, the integral of 1 over 1 plus x over 2 squared. We could write it that way. See? Could write it that way. And then I can say, okay, now let u equal x over 2. Then that means that du equals 1/2 dx. And then I could multiply by 2 and get that 2 du is equal to dx. Perfect. Now let's see what we have. We have 1/4 times 2 du over 1 plus u squared. And of course, this 2 and that 1/4 would make just a 1/2 out here. Yeah, there we go. And now the antiderivative then would be 1, well, okay, here we go. 1/2 arctan, running out of room here, of u plus c. Went right to the edge of the paper. Okay. And of course, we could write that as 1/2 arctan of x over 2 plus c, if we wanted to. Yeah. And then if you differentiate this, you would get this back. Okay, now let's do a little combination here. Let's suppose that I've got 1 over 9 plus 4x squared dx. Okay, let's see what this gives us. Now, there's a couple of things we don't like here. We don't like it that this is 4x squared, not just x squared, and we also don't like it that this is 9 instead of 1. So what I'm going to do is I'm going to factor out that 1/9, just like in the previous problem. And now I've got 1 plus 4/9 x squared. See? Because I wanted a 1 there. Now I've got a 1 there. I feel better. So now let's see what we've got. We've got 1/9. And now up here 1. And down here 1 plus 2/3 x squared. See? So now I write this as just one thing squared. And then I can apply the substitution. I let u equal 2/3 x. See that? Then du is equal to 2/3 dx, or 3/2 du is equal to dx. Yeah, there it goes. Now let's see what we have. We have 1/9 times 3/2, see, du. So I'll put a du up here, 1 plus u squared. And that's going to be, notice this 3 and that 9, they simplify down to, this is a 3, so this is 1/6 arctan of u plus c. And of course, the u we can substitute back in if we want to. This is 3/2 x plus c. There we go. And that's, there are some examples of how we would deal with these integrals that involve inverse trig. Now I just used here, all these were inverse tangent, involved inverse tangent. But you can do the same approach when you see that you're trying to find an antiderivative of something that looks like it involves inverse sine or inverse secant, something like that.